Bismillahirrahmanirrahim. In this lecture, I'm going to speak about the addition and the scalar multiplication of vectors. Starting with the addition, if we want to add or subtract two vectors. Suppose that we have two vectors. A is equal to A1, A2, and A3. Suppose this is a vector in three-dimensional space. And another vector B is equal to B1, P2, P3. The addition of A plus B is given by A1 plus B1. The first component will be added to the first component of the second vector. A2 plus B2 and A3 plus B3. This is the idea of addition of two vectors. For the addition, we have some properties. Speak about these basic properties. Of vector addition. First one, A plus P is equal to P plus A. This is for the commutative property. So they are commutative. Commutative property. Second one, A plus B plus C is equal to A plus, this is the associative property. Third one, A plus zero vector is equal to 0 plus A. Zero vectors, it's a vector with common 0 and 0. This is the identity. And number 4, A plus minus A is equal to 0. This is the inverse. The inverse is just a vector with the same magnitude but in the opposite direction. It is in the same magnitude but in the opposite direction. The negative sign will reverse the direction of the vector. If this is A, this will be minus A. Same magnitude, but in the opposite direction. So when we add these two vectors, I will get 0. It is like we have two forces against each other. The resultant force will be 0. For the basic scalar multiplication, scalar multiplication. But the scalar multiplication means that we multiply the vector by a constant, not a vector. If we multiply the vector by a constant, for example, the first one, let's say C is constant, it is not a vector, multiplied by A plus B. These are two vectors, can be written or can distribute the constant to multiply the first one and multiplied also by the second vector. We distribute the multiplication, take it inside. So this is the first property. The second one, I have sum of two constants. Say C is constant, it is not a vector. Means it is just a value, there is no direction for this one. This is the meaning of scalar. It is not a vector, it is a quantity with no direction, just value. So C plus K, where C and K are constant multiplied by a vector. This can be written as C multiplied by A plus K multiplied by the vector A. Third one, C multiplied by K times vector A is equal to C multiplied by K A vector. Number 4, 1 multiplied by the vector A will give me A. This is the identity multiplication or the multiplicative identity. So these are basic properties for addition or scalar multiplication of vector. Take one example or two. Find 4 multiplied by vector A minus 3 by B vector, or vector of B, given that A is equal to 3I plus 5J, and B is equal to minus 7I plus 3J. And we need to find 4A minus 3B. So I have A equal to 3I plus 5J. If we multiply it by 4, we multiply each component by 4. In this case, it will be 12I plus 20J. Multiply each component by 4. 4B or B we multiply by minus 3. Is equal to multiply by minus 3. Minus 3 times minus 7 is 21. I minus 3 multiplied by 3 is minus 9. J. So 4A minus 3B is equal to, just add these components. 12 plus 21 is 33I. 20 minus 9 will give me 33I plus 11J. Or I can use the other notation to write the vector. So the vector can be written either in this way using the standard basis of the space, or using this bigger and smaller than notation, which is 33. This is the first component, and 11. So this is the idea of scalar multiplication and addition or subtraction of two vectors. We multiply each one of the components by the scalar, and we add the x coordinate and y coordinate. Let's speak about the unit vector. Unit vector, it is a vector with magnitude equal to 1. So the unit vector is a vector with magnitude equal to 1, or that has magnitude equal to 1. A unit vector. For any vector, we have something called the normalizing or the normalization. Of a vector A, say, is given by U is equal to 1 over the magnitude A divided by A. This is the normalization or normal vector for any given vector A. Because the magnitude for this one, if we take the magnitude for U, it will be 1 over by the magnitude of A. That will give me 1. So the idea of normalization of a vector A, it is 1 over the magnitude multiplied by the vector itself. For example, given vector A is equal to 2 and minus 1, we need to form a unit vector in the same direction as A. Suppose that we need to find a unit vector in the same direction. So it is U equal to 1 over magnitude of A multiplied by A, which is equal to magnitude of A is equal to square root of the component 2 to power 2 minus 1 to power 2 multiplied by 2 minus 1. This is equal to 1 over square root of 5 multiplied by 2 minus 1. This is a unit vector in the same direction. Or I can write it as 2 over square root of 5 and minus 1 divided by square root of 5. This is a unit vector in the same direction of A. If I wanted to be in the opposite direction, if we want a unit vector in the opposite direction, all what we need just to multiply by negative. Let me call it V this time. V will be minus U. So it is minus 2 divided by square root of 5 and 1 divided by square root of 5. If we just multiply by negative, we just we reverse the direction of the vector. So V equal to minus 2 is a unit vector in the opposite direction of A. So to find the unit vector, we divide by the magnitude of the given vector. If it is in the same direction, leave it as it is. If it is in the opposite direction, multiply by negative sign. And that will be the unit vector.